And here we go. So, in this first section, we're kind of getting an introduction to some of the things that we're going to be working with. Chapter 2 is mostly about limits, but we do touch on derivatives as well. So, limits are really the foundation of calculus. Everything we do is built on limits, both derivatives and integrals. And those are really the two main halves of calculus, the derivatives and integrals. Okay? So in this course, we'll start off with limits. We'll get an understanding of those. Then we'll move into derivatives. What are derivatives? We'll do applications of derivatives, and by the end, you should be able to differentiate most functions thrown at you. Okay? After that, we will touch on integrals. That's what Chapter 5 is on. We won't get too far on integrals. Calculus 2 actually picks up with integrals. About half of Calculus 2 is about how to work with integrals. And then the second half of Calculus 2 is about series. So that's something to look forward to. Calculus 3 then comes back and says, let's do all that over again, but with multiple variables. So instead of just x as being our one variable, we'll deal with x's and y's and z's and vectors and stuff like that. Okay? So if you do well in Calculus 1, my belief is that you should probably do well in Calculus 3 as well. Okay? Calculus 2 is a little different. It's a little difficult, but you'll get to that point. Okay. So first, we'll start off, and in section 2.1, the first thing we talk about is a tangent line. Okay? A tangent line, as it says here in the notes, is a line that touches a curve at one point in some small area. So let me give you a picture here. Actually, I think I do medium. I think this one's more one. Okay. This is our tangent line. So it's touching the curve at this one point in that small area. Okay. Tangent lines turn out to be fairly important. Okay. Well, yeah, I'll keep on going. Isaac, I'll get to you in a little bit. So we have a tangent line here, and the next thing is a secant line. Now, I know that these kind of sound like trig functions. We're not really looking at trig functions here. This is the term that's applied here. So it's tangent and secant. When I say a secant line, I'm talking about something that touches the curve twice in a small area. So maybe that same point and somewhere else over here. So that's my secant line. Okay. And so my question for you is, what is this? What type of a line is this? Neither. Secant? Okay. This is actually a trick question. I'd have some fun. This makes a point here. This is actually a tangent line. It doesn't look like it though, right? It looks like, if anything, it should be a secant line. But it's not, because we're focused on a small area around our original point. So if this is my original point right here, does it touch anywhere around that? No, it really doesn't. I'm looking really in a kind of a very small area here around it, and I don't see it touching anywhere nearby. Okay. Now, yes, it does touch all the way over here, but look at how the function has changed then. It's gone from curving down to curving back up. The function's totally changed. So I'm not considering that point to be close to the original. Now, one question that comes up is, how close does it need to be a secant or a tangent line? Well, we'll actually look at that a little bit. Having 2.4, how close is close? For right now, it should be pretty obvious. Either the points are very close together or they're not. Okay, it's either a tangent line or it's a secant line. So, those are our definitions there. And the main question for us in this first section is, how do we find the equation of a tangent line? So I'm going to erase this. I'm going to move down. This is what I'm going to do right here. I'm going to wipe the screen. Again, this is recorded, so you can always go back and look at it again. But I'm going to scroll down. And I'm going to focus on this first example. Find the equation of the line tangent to y equals x squared at the point 1, 1. Okay? So I want to find this tangent line, and I want it to hit at that 1.11. So first off, what does the equation of a line look like? If I said, give me the equation of a line, what would you say? What does it look like? Y equals mx plus b. Okay. And this is only one way that we can write a line. This is what we call slope-intercept form. This is how we will write most of our answers. Okay? Because it's very easy to graph in this situation. We plot the intercept, the b value, on the y-axis. We use the slope to find a second point, and then we just connect them, and that's our line. Okay? So this is great. This is a form of a line. However, it's not the one... Is everyone okay? Okay. This is not the one... Oh, Newton's back. Good. Okay, hi Newton. That's really loud. Let's see, I don't know if I want you to change your audio or me to change mine.
Hey, this is Mustafa from Florida. Can I ask the guys from the other campuses to mute the mic? So I hear them all the background noise and things.
Yes, thank you.
Guys, you can repeat the microphone and answer this question. Thank you.
Thank you. Thank you very much. Okay, and if you do have a question, Newton, if you speak, your screen will come up, and then I'll try to address your question as we go. Still hearing a little background noise. We just started. Say it again.
Can you hear me?
Yes.
Okay, you're very helpful, and the physical control panel is not responsive.
Well, so what I would suggest here, let's try to do our best with what we can. I am recording this, and so you should be able to go online and listen to everything later as well.
Okay, thank you.
Okay. Where were we? Okay, so what I was saying was, we have this slope-intercept form of a line. One of the campuses, I think it's Newton. Can you mute the audio? Or you said it's non-responsive. Or maybe turn down the volume.
Hey, you can just push the button on the right panel. There is a physical button here, a physical audio button. Just push that. It will turn red.
Yeah. Now the cameras look like they're off again.
Got it?
Well, I don't hear them, so I think I got it.
It looked like technical support had just walked in there.
I wasn't sure if that was a student or not. We'll check here in a little bit. Let me continue here. I do want to try to get through some of this. We'll take a break and maybe they can... Oh, they disappeared again. Okay. We'll hopefully catch up online. So let's do a couple more things and we'll take a break. So as I was saying, we have the slope-intercept form of a line, this y equals mx plus b. There's another form that we'll use a lot as well, especially in this class, and that's called point-slope form. Okay? So does anyone know point-slope form of a line? No? No point-slope form? Okay, well you'll learn it after this section.
X2 minus x1 over y2 minus y1.
That's slope. We'll get to that in here in a second. Y minus y1 equals m times x minus x1. This is point slope form. We will end up using point slope form more because in most of these problems there's a point that we want to use. In this case we have the point 1, 1. And then we also want to find the slope. And so we'll do some work to find the slope. We'll put that into point slope form and then we'll simplify it to slope intercept form. So it's easier to read or easier to graph after that. So first off, I want to use point slope form. Okay? Now the nice thing here is, here's my point. Okay? But how do I find the slope? How do you find slope of a line?
Y minus y1 over x minus x1.
Slope we said is m is y minus, y2 minus y1 over x2 minus x1. This is our formula for slope there. Okay? So all we need are our 2 points. We plug in, we find the slope. We can plug that into point slope form, simplify it to slope intercept, and we're done. What's the problem that we have here? We only have 1 point. Okay? So how am I going to use the slope formula if I only have 1 point? Should I guess? Should I just pick another point on y equals x squared? What should I do? Well, here's the thing. With tangent lines, you only have 1 point. You're only given 1 point. You can't just pick a random second point there. Okay? Remember, if we're finding the slope of the tangent line, it only hits the curve once around that 1 point we have. So we cannot use our regular slope formula anymore. Not directly, at least. Okay. And so we have to be a little clever about this. We have to say, well, I can't find the slope of the tangent line using the slope formula, but you know what? I bet I could find the slope of the secant line using that formula. Why? The secant line has 2 points. It touches in 2 points. So maybe if I graph this, we're looking at the function y equals x squared. So it's our parabola. It has the following points: 1, 1, 2, 4, negative 1, 1, negative 2, positive 4. Now I'm interested in this 1 point right here. But maybe I'll create a secant line with a point that's fairly close by, and I can find its slope. Let me go ahead and draw on the tangent line, by the way. Here's what we want. So this is my tangent line. My line doesn't really touch the parabola. I'm drawing. I'm not the best artist. You get the idea. So the tangent line touches there, but if I take a point that's fairly close by, maybe I'll get something very close to the tangent line. So maybe let me take this point up here, because I already have one. Let's use the point 2,4. I can create a secant line. Can I find the slope of that? Yeah. Yeah. So let's calculate the slope of the secant line. So I'm using this point up here. This is 2, 4. Fingers writing. So my y value was 4 minus the original 1 that I had up here. y2 minus y1 over x2 minus x1. So 2 minus 1. And what does the slope come out to be? It comes out to be 3. So the slope of that secant line is 3. Now how does that relate to the slope of the tangent line? What can you say about it?
That's the M.
Okay. The 3 is the m for the secant line. What's the m of my tangent? Is it greater than? Less than? Exactly. Yeah, the slope of the tangent line will be less than 3, right? Because it's not quite as steep as the secant line. So my tangent line is less than 3. I also know that it's greater than what? 0. 0 would be a flat line, horizontal line. My tangent line is not flat. It does have some steepness to it. So I know that the slope of the tangent line is between 0 and 3. Now, where in there is it, I don't know. I'd just be guessing. Okay? So what I could do to perhaps have a better idea of what it is maybe find the slope of another secant line. Okay? Maybe, instead of using the 0.24, what if I use 0, 0 and create another secant line? Aha. I'll call that secant 2 there. So I've created another secant line. And I can find its slope. Now my second point that I'm using over here is 0, 0. So that's my x2 and y2. What's x1 and y1? 1, 1. That was the point given in the problem. This point over here. So I'm going to do 0 minus 1. 0 minus 1 there. So y2 minus y1. x2 minus x1. And what does that slope come out to be? 1. Just positive 1. Okay. So the slope of my my tangent line is somewhere between 1 and 3. Is it 2? I have no idea. Just because I've drawn it and it kind of looks halfway in the middle, that doesn't mean it is halfway in the middle. The slope could be 2.3, and I wouldn't know unless I actually found it. Okay? So our question comes out to be, well, how do you get a better estimate for the slope of the tangent line? So Anything you can think of there? I'll give you a hint. Let's do another secant line. Where would you choose your second point? And there's a lot of different answers you could give. Should I choose a second point up here on the curve, or maybe down here on the curve? Further down. Closer to the original point. Why closer? Because if I put a point closer here, look at that line. Actually, it actually goes this way, down here. That's okay. There's too many lines there already. But if I move this second point closer, the secant line gets closer to the tangent line. Let me write that down. We move the second point of the secant line. I'm going to hit myself. We move the second point of the secant line closer to the original point that we have. The secant line becomes closer to the tangent line. Okay. So we move that second point closer to the original point. Our secant line becomes closer to the tangent line. And that actually lets us find a slope that's closer and closer to the slope of the tangent line. Okay? Now, to get a really good estimate of the slope of the tangent line, I would need to move the points pretty close. Right? And so I'm going to do that. I'm going to keep on going here for today. Usually we'd have taken a break by now. This section isn't too long, so I just want to keep on going with this, and maybe we'll finish a little early, but let's keep on going with this for right now. So what I want to do is show you what will happen if we move that second point closer and closer. And so I'm actually going to pull up the calculator and have the calculator do that for us. I really don't want to get rid of this. Here we go. That's not what I want. There we go. Let's see if it pulls the calculator up. No, it's not going to cooperate. Okay. I hate to erase all that. Maybe I'll move this down so you can see it. No, we're just going to have to deal with all this. Sorry. Okay. So I'm going to go into y equals, and I'm going to, actually I'm not even going to do that. I'm just going to do this a different way. I'm going to go quickly here. So I'm going to go into list, or stat, right here, the stat button. And then I'm going to go to edit, which is option 1. Okay. And I want to choose some x values very close to my original point. What was my original point again? It's 1, 1. So choose some x values that are very close to 1. And I'm going to get closer to 1 as I move along. And I'm going to come to 1 from both sides, from numbers greater than 1 and numbers smaller than 1. So let's start smaller than 1. I could say 0.5. That's less than 1. 0.9 is even closer. What's closer than 0.9? 0.95, 0.99. I mean, I could really get as close as I want, right? 0.99999, you know. I could keep on going. I'm not going to do all that right here. Let's say that that's enough. Okay? Let's think of values greater than 1 that are also kind of the same distance away from 1. 0.99, how far away is that from 1? 0.01 away. So what's 0.01 greater than 1? 1.01. 0.9 is 0.1 away. So what's greater than 1 that's 0.1 away? 1.1. And then 0.5, that's 0.5 away, so let's do 1.5. That's enough. You really don't need a whole lot of these, and you can pick really whatever you want. I'm just choosing these values. Again, you can pick your own values. Now I'm going to go over to list 2, because I want the calculator to actually calculate all these slopes of all the secant lines all at once, so I can just look at all of them, and that will give me a good idea of what the slope of the tangent line is. Okay? So I'm going to tell the calculator, here are the x's, find the y's. And the way we do that is I'm going to move up. I'm going to highlight the top of list 2. And this is kind of where we program the calculator to do what we want with list 2. And I want to take the values in list 1, and what was our function again? Y equals x squared. So I want to square all these x's. And I could just do 0.5 squared, 0.9 squared, 0.99 squared. It's much easier to press the second button, second, 1, and that brings up L1 right there. Second 1 gives us L1. And what do I want to do? I want to square it. So whether you press the square button or you do the caret 2, it doesn't matter. But once you have it written like that, press enter. There's all the y values. Okay. So right here I have listed out 6 different points. All the x's, all the y's, and then I want to calculate slope. Okay. Now let's see if I can still write here. Okay. So to calculate the slope, remember that it's y2 minus y1 over x2 minus x1. Now our y2s are listed in L2 here. So if I write down L2, those are all my y2 values. Minus, what is y1? What's the y value of the original point? It's 1. Where does x2 come from? L1. Those are my second points. The x values are the second points. So L1 minus, what was my original x value? 1. Okay. So I'm going to tell the calculator to do this, and it will calculate all the slopes all at once. The way I'm going to do that is I'm going to move over. Go back. Okay. Let's see. Move over to list 3. Go up to the top of it. Highlight list 3. Okay. I'm going to enter in this formula over here, but I have to use parentheses to make sure it reads correctly. So I'm going to do parentheses. How do you think I'll get L2? Second 2. L2 minus 1. Close parentheses, that's the numerator. Divided by parentheses. Second 1 gives me L1 minus 1, close parentheses. There's my slope formula, and when I press enter, these are all the slopes of the secant lines. What do you notice as we get closer and closer to 1? It gets closer and closer to 2. from both sides. From below it, this 0.5, 0.9, 0.99, as our x value is getting closer to 1, the slopes are 1.9, 1.99, oh, sorry, 0.9, 1.9, all that. And as we come from the other side, it's going down to 2. So both sides are approaching 2. Okay? So looking at that, what would you say the slope of the tangent line is? 2. We'll say our slope is 2. And this is the slope of the tangent line here. Okay. So using the calculator and those approximations, we're fairly confident that the slope of the tangent line is 2. Now we could get closer if we wanted, and you'll see that the slope is indeed 2. Yes?
And that's because the closer we get to 1, the closer we get to 2.
The closer the x values get to 1, the closer the slope gets to 2.
Okay.
Yes. So again, we're taking those second points, we're calculating the slope of secant lines, and as I move that second point closer, it's getting closer to the tangent line, so its slope is matching up closer and closer. Any questions with that? Okay, so let me go back. I'm going to finish up this example right here. So we're saying that the slope of the tangent line is 2. Okay. Now we have everything we need to plug into our point slope form. It says y minus y1. What's our y1? 1 equals m, that's our slope, we found that was 2, times x minus x1, which we said was 1 as well. If I simplify this, put it in slope-intercept form, that is the equation of the tangent line. Actually, it's the equation right now. It's just not simplified very well. So solve that, and what do you get?
I equals 2x minus 1.
This is the equation of our tangent line. Okay? And my graph doesn't quite look like it, but it's pretty close.
Is that right?
Hmm?
I don't think that's right.
2x minus 1?
Because you don't have to add 1 to both sides. Doesn't
I do.
2x.
So I get 2x here, and I get a minus 2 there.
Okay.
Add the 1 gives me negative 1.
Okay.
Yeah. Okay. So that's the equation of the tangent line there. Any questions?